Bismillahirrahmanirrahim. This topic we are going to find the integration of exponential function. From the derivative of the exponential function, we know that d by dx of p of x equal to the derivative of the exponential function is given by b to power x multiplied by ln of b. And with a special case when the base is equal to e, d by dx of e to power x equal to e to power x. No change for the derivative when the base is equal to e, where e is constant number approximately equal to 2.71. Now for the integration, as we know, the integration is the opposite of the derivative. So if we want to integrate the function or the exponential function, integration of v to power x is equal to, for the derivative, if we differentiate v to power x, we will get v to power x multiplied by ln of b. And since the integration is the opposite or the reverse process of the differentiation, then the derivative or the integration of b to power x will be b to power x divided by ln of b. For the differentiation, we multiplied. For the integration, we divide by ln of the base. If the base is equal to e, then the integration of e to power x dx will be e to power x, the function itself. And since these are indefinite integral, we should add c, the constant, because these are indefinite integral. Now just to apply the concept for some examples, let's say evaluate number 1. See, integration of 2x e to power x squared dx. I know the integration of e to power x. That will be e to power x plus the constant c. Now any change in the power, if it is not x, e to power something, then I will apply the integration by substitution. I will choose the power to be u substitution and try to simplify the integration. So I will let u to be the power. It is x squared. This is by substitution. Now du will be derivative to x dx, or dx is equal to du divided by 2x. So the integration now will be 2x multiplied by e to power u. Dx is du divided by 2x. And we can simplify this one. I will cancel 2x with 2x. So I will have integration of e to power u du, which is equal to e to power u plus the constant c. Write it back. It is e to power x squared plus the constant c. So this is the integration of that one. It is e to power x squared plus constant c. Let's take another one. Number 2. Integration of e to power minus 5x dx. E to power minus 5x dx. We apply the same technique. I'm going to choose or let u equal to minus 5x. Take the power to be the u substitution. Then differentiate. Du will be minus 5 dx, or dx equal to du divided by minus 5. So the integration now will be e to power u dx is du divided by minus 5, which is equal, I will take minus 5 or 1 over 5 outside, e to power u du. And this will give me minus 1 over 5 e to power u plus the constant c, or it is minus 1 over 5 e to power minus 5x plus the constant c. One more example. Integration of square root of e to power x dx. We know that the square root means power 1/2. So this can be rewritten as e to power x or to power 1/2 dx, which is equal to e to power 1/2 x. Multiply the powers x and 1/2, I will get x over 2. So again, by the u substitution, I will say let u equal to 1/2 e to power, 1/2 x. This will give me du equal to 1 over 2 dx, or dx will be 2 du. Now the integration can be written now as e to power u, dx is du, or 2 du. So we can take 2 outside. I will have e to power u du, which is equal to 2 e to power u plus the constant c, or it is 2 e to power 1/2 x plus the constant c. We can say in general, the integration of e to power ax dx is equal to 1 over e to power ax plus the constant c. This is general rule for the e to power ax. Integration of e to power ax dx is equal to 1 over a multiplied by e to power ax plus c. This can be found by the integration by substitution. Example number 4. Integration of e to power tangent x multiplied by secant square dx. Again, I have e to power something different from x. I know the integration of e to power x is equal to e to power x, but if it is not x, I will use the u substitution technique. Say let u equal to the power, which is tangent in this example. So du differentiate tangent will give me secant square x dx, or dx is equal to du divided by secant square. So the integration now will be written as e to power u multiplied by secant square x dx is du divided by secant square x. Now simplify. I will cancel this one. With the other one. This is big. Okay, this with this one. Secant square with the secant square. So I will have integration of e to power u du, which is equal to e to power u plus the constant c, or it is e to power secant square, so tangent, plus the constant c. So it is e to power tangent x plus the constant c. One more. Example number 5. What is the integration of e to power x and e to power x plus 1 dx. I have e to power x up and e to power x plus 1 down. So let's see how to find this integration. This one, I will choose the denominator to be u substitution. Let u equal to e to power x plus 1, because the derivative will be in the numerator. That will be easier for me, because the derivative of this one, du, equal to e to power x dx, or dx is equal to du divided by e to power x. So the integration now will be integration of e to power x divided by u multiplied by dx, which is du divided by e to power x. So e to power x will cancel e to power x, and I will have in this case integration of 1 over u du, which is equal to ln absolute value of u plus the constant c. Integration of 1 over u is equal to ln absolute value of u, and write it back. I will have ln u is equal to e to power x plus 1 plus the constant c. So this is the integration for that function. That was number 5. Now number 6. Let me take e to power 2 then x dx. As we said before, take the power to be u substitution. Let u equal to 2 ln x. So du in this case will be 2 multiplied by 1 over x dx, or dx is equal to 1/2 x du. Dx will be 1/2 x du. So the integration now will be e to power u multiplied by dx. Dx is 1/2 x du. Now I have a problem in this question, because still I have x there. After the u substitution method, we shouldn't have any x in the problem, but I have x. So we have to remove it from the integration, because my integration now is in terms of the u variable. I have e to power u and du. So x must be removed or written as a function of u. Now from this relation, I will say 1 over 2u equal to ln x. This will give me x if we use or convert the logarithmic function to exponential function. It will be e to power 1/2 u. X equal to 1 e to power 1/2 u. This is by converting the logarithmic form to exponential form. So the integration now will be written as e to power u multiplied by 1/2 x is e to power 1/2 u du. Take 1/2 outside, it will be 1/2 e to power u multiplied by e to power 1/2 u du. And since we have multiplication of two numbers or exponents with the same basis, we can add the powers. So this is 1/2 integration of, if we add the powers u plus 1/2 u, I will get e to power 3 over 2u du. Now for the integration, this will give me 1 half and e to power plus constant c. But for the power, this one, I will divide by 3 over 2 or write it as 2 over 3, just upside down. Write it upside down. 3 over 2 will be 3 over 2 because we are dividing by this exponent. Now write the value of u. So I will cancel this. With this one I will have 1 over 3 e to power 3 over 2 multiplied by u is equal to 2 ln x plus the constant. So I will have, I can cancel 2 with 2. It is 1/3 e to power 3 ln x plus c. Now this is if we use the u substitution. But there is another way which is easier than this one. Let's go back for the problem. I have in my question it is e to power 2 ln x dx. Now if we use the properties of the logarithmic function, this will be e to power ln x squared. Let me put this is another method. We know from the logarithmic property that if we have exponential with the logarithm with the same basis, then they remove each other. This is one of the properties of the logarithmic functions. So I will have in this case only x squared dx, and the integration for this one we will add 1 to the power, it will be 3, and divide by that number, it is 1/3 x to power 3 plus the constant c. See, this one is easier. Are they the same? Say yes, they are the same, because this will be power, so it is 1/3 e to power ln x to power 3. So this will cancel this one. I will have 1/3 x to power 3 plus constant c. You can see they are the same. So either you can use the u substitution or you can use the properties of the logarithms to make the integration easier and evaluate. One more, that will be number 7. Now what will be the integration of e to power tan inverse x divided by 1 plus x squared? It seems to be complicated in this way or in this form, but let's just try to use the u substitution technique to see will it be easier after the substitution or not. So I'm going to take the power, let u equal to tan inverse x, then du, the derivative of the tan inverse is 1 over 1 plus x squared, and dx there, because I'm using only du. So dx is equal to 1 plus x squared du. So my integration now will be e to power u divided by 1 plus x squared multiplied by dx. dx is 1 plus x squared du. Now we can see this 1 plus x squared will cancel the other one, the denominator. So I will have only integration of e to power u du, which is equal to e to power u plus constant c and this can be written e to power tan inverse x plus the constant c, and that's it. So the integration is equal to tan inverse x plus the constant c.